Welcome back. So we've covered an introduction on statistics, and one of the things we said was we are trying to make studies about a population, and it'd be nice to be able to do a census because then we know the parameter if we did that. But reality, that's not realistic. We're likely not to be able to do that. So we have to collect data in different ways. And some are simple samples. Another way is a simulation. And we start with simulations because we know students are in and out of class in that first week of school. And while this is important, it's not going to kill someone if they miss this section. That said, it does show up somewhat frequently on the AP exam, but it's not highly tested. So basically with a simulation, the awesome thing about a simulation is we can model real world results and it'd be fairly inexpensive. Matter of fact, my wife models catastrophes, and she'll do like 1,000 iterations for catastrophes for a insurance company. So basically, it's a way to do things over and over again, somewhat inexpensively when we carry them out. First off, we must employ randomness. All right, as I said, it's more economical and it's faster. Typically, we can use a model to generate the same information. And the other nice thing about it is because it's a model and it employs randomness, it's fair and it's not biased or prejudiced. All right, and we'll talk more about bias later this week, one of the fun topics to discuss in class. So randomness. Random is not like what comes out of my mouth and you never know what's going to happen. Usually I don't know either. That's not the type of random we are talking about. It's that we actually know the possible outcomes that can occur, but we don't know which one will take place. Like when we flip a coin, if the coin's a fair coin, we know that we can either flip it and get a heads or we can flip it and get a tails, but we don't know which one is going to happen. So that's randomness. Rolling a dice the same way. If we're rolling a 6-sided die, we know we're going to get a 1, 2, 3, 4, 5, or 6. But assuming it's not been rigged, we don't know which one is going to occur. When we talk about simulation, sometimes we'll use the term component. And a component is the thing that you continuously continuously repeat. Oh, we flipped a coin 50 times. We rolled the dice 10 times. The outcome is what you got. Oh, we got 5 heads and 4 tails when we flipped it 9 times. A trial is the number of components necessary to model a situation, and that'll make more sense. And a lot of these definitions will later. So I'm going to move on and actually run one in just a moment. I do want you to get used to looking at recipes. We don't use many of them in the first semester, but they became super important the second semester. So first off, read the entire problem and ask and figure out what are they asking for. Generally speaking, I'm not going to ask you to write that down, but you need to go, gosh, what is it they want to know? Explain the question in your own words. And when you put in groups, talk it out. Hey, this is what they want us to know. This is what they want us to do. We need to determine what a success is. Maybe a success is rolling a 2 on the dice or flipping a heads on a coin. And the component, of course, in those cases would be either flipping a coin or rolling a dice. Identify how many successes are required. Maybe I'm going to flip the coin until I have 5 heads. Well, that means the trial could be as short as 5, or it could take forever because we may never get 5 heads. To model the simulation, we have to assign numbers. All right, because we're going to be working with a random number table, and usually we assign 1 or 2 digit numbers. Now you can assign as many digits as you want, but the fewer digits you assign, the faster it goes. I have an example of 2 digits. So typically speaking, I say 00 represents a 0, could represent 100. So the 00 could represent either one, but 01 represents 1, 02 represents 2, 03 represents 3, all the way 09 representing 9, etc. And then 99 would represent 99. You're like, well, why couldn't you just do 100? Well, 100 had 3 digits, and we said we were only going to use 2. So consequently, we go, oh, 00 can represent 100. All right. Now, sometimes we represent 0, we use it to represent 0, but it depends on, you're going to have to define that. Really important that you define things or assign. You also to say what numbers are going to be skipped. Maybe you don't need all the numbers. And then another thing is duplication. Are duplicates or repeats permitted? Sometimes they are. Percentages usually can be duplicated. And I'm going to say almost always. So if it's a percent, they're asking you to do a percent. They're saying, oh, we have an infinite population. Don't worry about it. Specific items can't be. So basically, if I have 10 people, I can't choose the same person twice for the same team. Okay. Then we're going to explain how to run the simulation, and then we'll take how many trials. Then ultimately, we're going to count up and make a table of the number of successes, and we'll take an average. All right. And then finally, we're going to state our conclusion. Based on our simulation, on average, you would expect to have to flip the coin 10 times in order to get 4 heads, all right, or whatever it is that we're doing, right? And you need to follow these sentence stems really closely, right? Because they're very well tested and work quite well. So let's look at our very first problem. This is on page 7 of your note spiral. So every Monday, a local radio station gives coupons away to 50 people who correctly answer a question about a news fact from the previous day's newspaper. So we're giving away 50 coupons, all right? The coupon given away are numbered from 1 to 50, with the first person receiving coupon 1, the second person receiving coupon 2, and so on, until all 50 coupons are given away. On the following Saturday, the radio station randomly draws numbers from 1 to 50 and awards cash prizes to the holders of the coupons with these numbers. Numbers continue to be drawn without replacement. All right, so that means no duplicates until the total number amount awarded first equals or exceeds, so equals or exceeds $300. The selected coupons 1 through 5 each have a cash value of 200. 6 through 20 have a cash value of 100, and coupons 21 through 50 each have a cash value of 50. So it starts off, explain how you would conduct a simulation using the random number table provided below to estimate the number of prize winners. So we're going to use this table on how and learn how to actually conduct the simulation using that. Well, one of the very first things I need to know is, well, what's the question? They want to know how many prize winners. Well, that's what they're looking for, is the number of prize winners. But we stop. So how many prize winners do we take? Well, we don't know. We keep taking prize winners until we get $300 or more, whichever, all right, $300 or more. So what's a prize winner? Well, a prize winner, it was 1 through 5, got 200, 6 through 20, have a cash value of 100, and 21 through 50. So we need to come up with an assignment. So what I would do is I would assign 01 through 05, because those are 2-digit numbers. And I knew I had to be 2-digit numbers because I had all the way up to 50 possible winners. All right. So 01 to 05, those are $200 valuations. And then 06 to 20 are $100 valuations, and 21 to 50 are $50 valuations. Now, some people go, hey, do I have to write it in sentences, or can I put it in bullet style format? And the answer, I prefer bullet style format. I just didn't have room here. All right. But you can write it in sentences, but it's much easier for me to grade. I would assign the following digits: 01 to 05, $200 valuation; 06 to 20, $100 valuation; and 21 to 50 are $50 valuations. But if we're thinking about this, I basically had these numbers. I had 00, 0, 1, 0, 2, dot, 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 99. I didn't need all those numbers. I didn't assign 0, and I didn't assign anything above 51. So 51 to 99 and 0, 0 are skips. That means they're nothing. They don't count. They're not prize winners. So we need to say that. I would skip 0, 0 and 51 to 99. Then I need to explain how I'm going to conduct it. This is going to be some sentences. And I'm going to say working from left to right. And you're like, do I always have to? Yes. And the reason being, we read from left to right. All right, makes it easy. So I'm going to work from left to right. I would select two-digit numbers at a time, skipping any duplicates. There, I addressed the duplicates until the sum of the valuation was greater than or equal to 300. So as soon as I get to 300 or greater, I stop. I would then count the number of selected two-digit numbers between 0, 1, and 50, which would be the number of prize winners for that trial. To increase accuracy, I'd run the simulation a bunch of times. I said 20 times, but really we want to run it a bunch of times and find the average number of winners, and that would be the expected number of prize winners. So continuing on, and by the way, you might want to pause the video to write this down, all right? So perform your simulation 3 times. That is, run 3 trials. In other words, they want me to do it 3 times. Start at the leftmost digits in the first row and move across. Make your procedure clear so that you can follow what you did. You must do this by marking directly on or above the table. Report the number of winners in each trial. Well, the first 2-digit number I come to is a 72. That's a skip. The next one is a 74. Now this is weird, but I can go across. And you're like, well, why do they have these spaces? They have these spaces in order to make it easy. Oh, 33. That's a winner. All right. And we said, you know what? What did we say? Those numbers 21 to 50 got $50. So this one won $50. All right. Oh, 47. That's another winner. 50. 65. Loser. That's a skip. It's not really a loser, just didn't get anything. And then we have 03. And we said 03 wins $200. Well, right there, that's the end of my trial. Well, how many people actually won that week? Well, I had one winner who won 50, another winner who won 50, and another winner who won 200. So I ended up with $300. Okay. So my winners were 3. So I had 3 winners. And you're like, well, what about this, this, and this, and those? Those were skips. They were nothing. They didn't get called or anything. So then we go down to the next trial. Now, technically, I could have started right after this. I can start right after the line or anywhere I want to. But when possible, it helps to drop to the next line. It makes it easier to read. It just makes it easier to conduct. Well, 81 was a skip. 63 is a skip, 83 is a skip, 65 is a skip, 66 is a skip, 42, winner, chicken dinner, $50. 70 is a skip, 93 is a skip, 37, winner. 17, and they get 37 is 50. 17, that's a winner, that's $100. 59 is a skip, 94 is a skip, 31 got us 50, and 20 got us 100. When I add those up, they sum up to $350. You're like, well, that's too much. And you're right. We wanted 300 or more, but 50, that's 100, 200, 250. So that's not enough. So we get to here, that's not enough. So we had to go one more. The next winner took us over to 350. So we had $350 that week. And we had 1, 2, 3, 4, 5 winners. The next week, we had 38 is a winner, 49 is a winner, 94 is a skip, 64 is a skip. You're like, wait a second, Mr. Spencer, that 38, that's a 38. 38 should be a winner, chicken dinner. And I'm like, oh, remember, no duplicates. So since we had already selected it, we couldn't select it. So it counts as a skip the second time. Then 91, 57, 90, then a winner, and then a winner. We had 1, 2, 3, 4 winners that week. So we had 3 winners the first week, 5 winners the next week, 4 winners. We add all that up, and we ended up averaging with 4 winners. And the question was, and what was the question? How many winners do we expect? Based on the simulation, I would expect there to be 4 prize winners a week. Now, they didn't ask this second part, so I didn't need to include it. But they could have asked, how much would you expect to have to pay out each week? Well, based on our simulation, I would expect to have to pay an average of $317 a week, right? So that's our first example simulation, and we'll do another one in the next video.